The moon's gravitational pull is 1/6 of Earth's gravitational pull. A person weighing 150 pounds on Earth would weigh no more than 25 pounds on the moon. Imagine how far you could jump on these two places.
So, according to the previous video, gravity and weight are closely related concepts. Weight is the force exerted on an object due to the gravitational attraction between the object and another massive body, such as Earth. The weight of the object is equal to the product of its mass and the accelerations due to the gravity. So let's check it out who is discover the gravity.
Sir Isaac Newton, a well-known scientist, discovered gravity about 300 years ago. The story is that Newton saw an apple fall from a tree towards the ground. At first he thought, why didn't the apple go up? Then he realized that there was a force that made it fall on the ground.
Everyone, I hope all of you are doing fine. Welcome back to physics classes for Form 4. So finally, we have reached us at the last content standard in this chapter, which is weight. So before we begin as usual, let us check the learning standard which you have to fulfill. So the one leading standard only where the end of this video, hope each and every one of you will know how to describe really as the gravitational force object with the formula of W equal to mg. Definition of weight. Weight is a force experienced by an object due to the gravitational pulls of Earth or any other celestial body. It is a vector quantity and it's measured in Newton. Let's begin our lesson by checking on these measuring tools. I believe you know these tools and you're familiar with them. So we have A, B, C and D. Can you give me the names of each of them? So, what is the first tool? What is the name? Very good. This is we call triple beam balance. How about B? Can you recognize B? Yes. B we call is level balance. And then what about C? C we known as spring balance or Newton balance. And D we call as compression balance. Okay, now if you refer to A, B, C and D, can you tell me which one using measuring weight? So it is C and D. Spring balance and compression balance is used to measure weight, while triple balance and level balance is used to measure mass. Very good. Between weight and mass. Weight and mass are often used in interchange applying in everyday language, but in physics they have a difference meanings. Mass refers to the amount of matters present in object and it is measured in kilogram. And then weights on the other hand depends on the mass of an object and the acceleration due to the gravity. The weight of an object can be calculated using a formula weight equal to mass times acceleration due to the gravity. Do you know what are the differences between mass and weight? So let's check on them by looking at these tables. Number one, you can differentiate them by their meaning definitions. So what is the definition for mass? So mass refers to amount of matter in a body. Then how about weight? We define as a gravitational force acting on a body's second differential. Yes, mass is have remained same everywhere since about the amount matter does not change. Wherever the object go well, how about weight? Weight of object, yes, it's changing due to the gravitational field strength on the places. And then the third differences, we can say that this is the base and scalar quantity while weight is the derived quantity. It's also vector, and we can talk about symbol. This symbol for mass is m and measure in unit of kg, kilogram. While for weight, the symbol is w and it's measured in a unit of Newton. And hope now all of you clear how to differentiate.
So it's time for exercise. Example 1. Let's go check it out.
So I want to share with you a tips to answer the question or solve the problem very easily. So we have first step, which is 2L, 2S. What is the first L? The first L is list the information given inside of the formula. If you see the information, just list down for the first step. And then the second L is list the formula related to the question. For example, this chapter, weight. So you jot down the formula related to the question. And then we go to first S, which is substitute. The third step, substitute the value inside of the formula that you have list. And then the last S is solve the problem. I hope all of you can get this tip to answer and solve the problem regarding to the chapter. Let's do the example for this chapter, which is the first example. So let's read the question together. An object has 8 kg of mass and weight 100 Newton on planet. Find the gravitational field strength. So, according to what I have teach you within 4 steps in solving the problem, which is the first step is find the information given inside of the question. So, let's refine the information given together. So, an object has 8 kg mass. So, this is the first information given, which is 8 kg of mass. And then, and weight 100 Newton on planet. So, this is the second information given, which is weight 120 Newton. So, find the gravitational field strength. And then, list the information given first, which is we got mass equal to 8 kg, and then weight we get 120 Newton. We go to the second step, which is find the formula or list the formula, which is according to this chapter we want to find the gravitational field strength. What the formula we're gonna use? Correct. W equal to mg. So, what is the third step? The third step is substitute the information given inside of the equations into the formula. So, we substitute the information into the formula, which is weight 120, mass 8 kg, and then we want to find G. So the last step is we solve the problem. So we make G as the subject first. The first step, make G as the subject. G equal to W divided by G divided by M. So the value of G is 120 divided by 8. So calculate using your calculator. What is the value? Correct. The value is 15 Newton meter kg negative 1. That's correct. So, I hope all of you understand.
Example 2. Let's go.
Now, let's check on these exercises. You are given a helicopter with a mass of 600 kg. What is the weight of this helicopter when it's land on the peak of a mountain, where the gravitational field strength 9.78 Newton per kg? Again, we apply the W equal to mg. Very good. Where mass is 600, gravitational field strength 9.78. So this will give you a weight of 5,868 Newton. Can I ask you a question? Why do you think gravitational field strength when at the peak of the mountain is a bit less compared to Earth? Gravitational fields of 9.8. Yes, very good. This is due to the altitude where it is further from the center of the Earth. So definitely the gravitational pull is weaker. So that's all from chapter 2.8, which is weight. So regarding to this chapter, we will learn about what is the meaning of weight and the formula of weight, which is W equal to mg, and then the comparisons of weight and mass, and then the last is we are able to solve the problem regarding to the weight. So I hope all of you enjoy these classes. So that's all from me. Thank you.